Hey guys, MEP Guy here, and in this video I'm going to show you guys how to find a sanitary invert inside of Revit. So the first thing we're going to do is we're going to draw our sanitary piping for the worst case scenario. So we have the main on the street, and this is the sanitary main that we're going to eventually connect into, and Civil's going to make that connection. But our sanitary piping is going to originate from the building. Now, what we're going to do is we're going to connect in this area right here. We're going to use this manhole as our connection point. So the civil engineer is likely going to provide a pipe from that manhole to our building at about a location right here. And so what we can do is, they're going to size the pipe based on what we need. So we'll say it's a 4-inch piece of pipe, and it's going to be in a location like this, and it's probably going to be, connected to this manhole, just like that. So now our job is to find the invert of our piping going out of the building. So what we'll do is we're going to start the worst case, so we get the furthest drop that would be necessary to make this connection. So all we have to do is start drawing some piping, and we're going to make sure we put it on the sanitary system, and we're going to use the correct pipe type. I'm going to use the sanitary PVC. And the first thing I always tell people is to drop it down to -2 feet. And the reason we do that is because basically when you get all the elbows and everything under the slab, it's going to be approximately 20 inches or something, but I always make it 2 feet to just give myself a little wiggle room. So I'm going to go -2 feet, and then we're going to set the size of our building's sanitary system. Now it depends on the size of your building, whether you're going to use a 4-inch or a 6-inch, and that's dictated by the International Plumbing Code. So we're going to start drawing from this corner because this is our worst case scenario. And we're going to make sure we have our slope down, and our slope's going to be at 1/8 of an inch per 12 inches. And we're just going to go at a point right here, and we're just going to start drawing some piping. Revit will snap when we get to the point where it's going to intersect the civil pipe, and then we're going to go all the way out to a point about right here and hit escape. Now what we're going to do is we're going to just visualize and see where we are in relation to the civil piping. So I'm going to open up a 3D view. So now that I have this 3D view open, you can kind of see, if we take a look, our piping is right here, and it's originating and coming over. And you can see that the civil pipe is much lower elevation. So that means we can easily make this connection to this piece of pipe. They're probably going to have to put some kind of drop here to make that connection. But the civil engineer might also just see the invert at our building and say, maybe we're going to make the connection up here. So they might bring this pipe up quite a bit. So let's try maybe -4. -4. And so maybe the connection will be something like this, and Civil will make sure this connection gets made, and then this pipe will get connected into the manhole. And this work will all be done by the civil engineer. And so basically now we have to figure out what is the invert elevation of this piece of pipe right here. Now the invert elevation is the elevation at the bottom of the pipe. Okay, that's your invert. Now if we click on our pipe right here, you can see that there's a little elevation right here saying it's -3.2. Now we want to make sure we have the bottom elevation. So this number actually represents the middle elevation of this pipe. So if we go over here to our properties, you can see there's all these different properties for the elevations. So we have an upper end top, a lower end bottom, upper end center line, lower end center line, and a lower end invert elevation. Now, a lot of people think to use this one, but that's actually the interior of this pipe. So we actually want to use the lower end bottom elevation. And luckily we can just go ahead and select it right here, and I can copy it to the clipboard by hitting Control C. And then we can go back to our floor plan view, and we can maybe put a tag here. So I'm just gonna go to annotate. We're gonna use a text, and I'm just going to put a text tag, and I'm gonna Control V and paste it. And we're just going to put that number right here. Maybe we'll add a liter, and we'll do something like this. Now this number represents the elevation of this pipe in relation to our FFE, or our finished floor elevation. So you can see the finished floor elevation is at 100 feet, and that's above sea level. So what we need to make sure is we need to let the contractor know that this distance right here is below the FFE, just like that. Now I wanted to make sure that was all caps. So now we have this number right here. Now another thing I'm noticing, I want to make sure that this is rounded correctly. We don't really need 3 decimal places. Typically the civil engineer is going to use 2 decimal places, but I usually just use 4. It's totally up to you guys, but you could do something like this. So that just looks a little cleaner. And we could even, if we want to, give ourselves a little more wiggle room and just make this 3.5 feet below the FFE. So that's going to be our invert elevation for our building sanitary. Now, for this project, I'm actually going to have a grease waste pipe that's going out the building in this location and hitting a grease interceptor. So I'm going to do the same thing. So I'm going to just go ahead and create similar. I'm going to start at -2 feet. We're going to slope down. I'm going to pick a point about right here, and then I'm just going to draw the piping all the way across here to a point about right here, just like that. Now I want to make sure I change this pipe to the grease waste system. So when I hit the drop down, you can see that I have created this grease waste piping. And basically all that is it's a copy of the sanitary system, and I've just renamed it grease waste since it's very similar. So now we have this piece of pipe, and I've also changed the color of the system as well. So let's go back to the 3D view, and let's kind of take a look to make sure that we're not intersecting. So right here you can see that even though this pipe's at -2, it clearly goes over the top of this sanitary pipe right here, so there's no issues there. We also can kind of take a look at the invert over here. So you can see at this point we have this elevation saying it's -2.896, and that's from the middle of the pipe, as you recall. So if we click on it, you can see that over here we have the lower end bottom elevation at -3.08. So I can copy that to the clipboard, and then I can go ahead and just copy this tag over, and then we can go ahead and just paste in this value and make sure we round up to the nearest 1/10 of an inch or foot. So right there we went ahead and we kind of calculated our inverts out of the building. Now that is a way to do it, and that's what most people are probably going to do, but I want to show you guys the smart way to do things, and it's kind of cool. So what we're going to do is we're going to use the power of Revit to do this for us automatically. So I'm going to delete these tags right here, and what I've done is I've created 2 types of tags. One is a pipe tag that takes the information from this pipe and displays it in a pipe tag. So if I go up to annotate, tag by category, you can see I have this pipe tag right here that automatically finds the invert elevation of this piping. I'm going to click, click, and click. And you can see I have this pipe tag that reads the invert elevation of this pipe. Let's create another one. So I'm going to use the create similar command, and we're going to click on a point right here on this piece of pipe. We're going to do the same thing. So now you can see I've went ahead and I've automatically tagged the pipe, and I've taken the information that lives in this pipe, or the parameter values right here, and I'm displaying them in this tag. So if I open up this tag, you can see that this is a label, and if I go to edit label, you can see that I've created, or I've moved over the parameter value lower end bottom elevation. I've created a prefix called invert. I got a sample value, a break, meaning that it's going to go to the next line, and then it's going to display some text. It's going to display below FFE. So that's how I get invert -10 below FFE. Now maybe I want to also put in a value, and so what you can do is you can go to units right here, and you can see I'm going to go ahead and unselect unit project settings, and then I want to make sure that I change this to feet. That way I can round, so I'm going to round to the nearest 1 decimal place, and then I'm going to change the unit symbol to this little feet marker, and that way I'll have a little feet right there. So I'm going to click OK, and then we're going to load it back into the project, overwrite the existing, and now you can see I have updated my tag to read -3.1 feet. So that's looking really good. Now there is one problem with this tag. Even if I create similar and I try to tag this piece up here, it's going to read the same value. And the reason it's going to do that is because it's using the lower end bottom elevation. So regardless of where you tag the pipe, it's always going to tag or update / display the value of the lower end elevation of this pipe. So we need to do it another way. So if I want to check the invert at a certain location, maybe I want to check the inverts of these pieces of pipes right here. Well, I've done another tag, but it's actually called a spot elevation. So I'm going to go to annotate. I'm going to click on spot elevation. And right here, you can see I have this one that's called relative to FFE. And so if I click anywhere near the pipe, you can see it's going to read the elevation of this piece of pipe. So maybe I want the elevation of this pipe right here, this green one. So I'm going to click, 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 and then I'm going to move this little text over right here. And as you can see, I have now the invert below the FFE equals -2.94 feet. Now I want to also display the invert of this grease waste piping in orange. So I'm going to do the same thing. I'm going to create similar, and now I'm going to select the invert of this orange pipe. We're going to do the same thing. Let's go like this. Let's move this over. Now let's go ahead and talk some more about the sanitary inverts on the street that are going to be installed by the civil engineer. So let's take a look at the manholes and the sewer on the street. So let's go back to our 3D view. And so now you can see that we have these manholes, and you can see that the pipe is sloping down right here. They hit a manhole, and then another pipe comes out of that manhole. And then the same thing happens, it goes in, and then it slightly goes down, and then it's going to hit another pipe. Now these manholes are required basically so they can have access to the sanitary sewer, and they can use it to clean out these pipes if needed. So since we have those really cool tags, we can go back to our floor plan view, and we can actually just measure any spot along these pieces of pipe to find the invert elevations. Now you won't have these manholes and piping drawn in your projects if you are just a plumbing engineer. So a lot of times you'll just have information right here. Now we have this MH dash, that stands for manhole dash 1, and this is manhole dash 2. Now you'll also see this STA 6 plus 00, and what that stands for is station. Now back in the day, they used to use these chains to measure distances, and they would use a chain that was 100 feet, and what they would call that 100 feet is one station. So if this is station 6, that means it's 600 feet away from the origination point of the sanitary sewer. So we have 600 plus 00, meaning it's 600 feet away. Now if we have this station 7 plus 10.5 feet, that means this station is 700 feet away plus 10.5 feet. So the distance from this manhole right here, to this manhole right here is actually 100 plus 10.5. So 110.5 feet. So I just wanted to explain that real quick. Now the invert in would be the invert into this manhole. So if we look back on the 3D view, the invert in would be the invert at this point right here. And then the invert out would be the invert out of the manhole. So it's coming in right here and going out right here. So invert in, invert out. Now they also might give you the manhole bottom invert, and that's the distance right here. And then they also might give you the manhole top. Now the major difference between how the civil engineer displays the inverts based on how the plumbing engineer displays the inverts is the civil engineer is going to use the absolute elevation, meaning the elevation from sea level. So in this project, you can see that we have this FFE 100 feet. That means that the finished floor elevation of this building is at 100 feet. So all the inverts on our sanitary sewer are going to be based on sea level. So this invert in, we can measure it. So if we go to our 3D view, we click on our pipe, we see that we have the lower and bottom elevation at negative 9.5. So we could copy this value right here, go back to our floor plan, and we know our invert in is negative 9.5. We're just going to round to 2 decimal places. Now our invert out, let's go to the 3D view. Let's click on our pipe. Now we got to be careful. This time we want to use the upper end top elevation or upper end bottom elevation. So you can see we don't really even have that value. So we might have to measure that value. So I'm going to go ahead and bring in the south view. So we're going to go click this. So you can see we have this nice view right here. And let's zoom in on this manhole. And you can see I've already created these measurements for you guys. Now, if you ever need to change the units of measurement to maybe decimal feet, I'm going to show you how to do that real quick. You're going to go up to Manage, Project Units, and under Distance, click on it. And then as you can see, you can change the distance right here, but we actually want to change the length. So I'm going to click on length, and right now it's at feet and fractional inches, and we want to change that to feet. And that way we can measure or round to the nearest decimal place. So we're going to round to 2 decimal places because that's how civil likes to display their things. And then the unit symbol we can change to that little feet marker. Click OK, click OK. Now you can see we have these nice dimensions in decimal feet. So then we can use this value right here. So I could double click, I could copy this value, negative or 9.5, cancel, go back to our plumbing floor plan. You can see it's negative 9.5. But remember, the reason why we did this is because we wanted to measure this distance right here. So I'm going to click on this guy, double click. We're going to copy this value, and this is going to be our invert out. So this was our invert in, negative 9.5, and our invert out is negative 10.69. So let's go back up. We'll go invert out, we'll control V, paste it in there, negative 10.69. And then our manhole bottom, we'll go back. You can see that's 12.5 feet from our level 1 down. So it's going to be negative 12.5, just like that. So now we have all those values filled in right there. And so we would probably want to do the same thing over here. So I'm going to go back to that south elevation view. And you can see that I've already went ahead and measured the distance from this manhole to this one. And as you recall, it was 110.5 feet away. So this time, let's go ahead and use our little smart tags. Oh, one thing I need to mention. Remember that the civil engineer is going to use absolute elevations. So as you can see, our level 1 is at 100 feet above sea level. We need to make sure we convert these distances or elevations to sea level. So let's go back to our first floor. We need to make sure we use elevations relative to that sea level or our actual elevation of our project. So I have a cool little thing that I also created. So I'm going to go back to the annotate, click on spot elevation. And right there, you can see I created one called relative to FFE or finished floor elevation, but I also created another one. And I created one called project elevation. And this one measures the actual elevation relative to the project. So as you can see, if we click on this point right here, we have 90.5, and that's measuring the invert of the bottom of the pipe relative to sea level. Now, if I do this again, I'm going to create similar. I'm going to do the same thing over here. And you can see this one is 90.32. So these are the actual values we're going to want to put right here. And so I can also do this for the invert of this manhole. Well, it doesn't look like I can because I can't register which one it is, but that's not a problem. So let's go ahead and update these values. So this was 100 minus 9.5 or 90.5. So let's update that. This one was 90.32. We got to get rid of the negative sign. 90.32, move that. And then our last one, we would just take 100 minus 12.5. So I'll let you guys do the math on that. I believe it would be 87.5. So that's how it would be displayed. And if we did it over here, we could use those tags again to create similar. And I'm going to go ahead and make a tag here. So this looks good. I'm going to move this over. That looks great. Let's create one more. Move this over. And then we would just need to update the values here. So I hope you guys enjoyed this. Now, if you are interested in a more slower paced video of how I created all of these tags, and you want to get your hands on these tags so you can use them in your projects, go to mepguy.com and I'll have this invert elevation course available with a very thorough explanation of invert elevations and also access to all of the pipe tags that I've created in this project. So make sure to check it out at mepguy.com, and I will see you guys in the next video. Bye.